Students, today we're going to do Pythagoras' theorem. So we need to know what the theorem is. We need to understand the relationship between the sides in a right angle triangle, and we need to be able to apply the Pythagoras' theorem to solve problems. For your starter problems, I'd like you to pause the video and spend no more than 10 minutes doing these questions. When the 10 minutes is up, resume the video and check your answers. Okay, so it says we need to work out the value of the expressions below. So for the first one, it says work out x squared plus y. So we're going to do x squared. So that means we're going to replace the x with 2 because it says when x is 2. So that means we'll have 2 squared. And then we're going to add y, and y is 2. So we work out 2 squared is 4, and then we add 2 to make 6. Next question, we need to work out x squared plus y squared. So we need to do 3 squared because x is 3, and then we're going to add 4 squared because y is 4, and then we'll work out 3 squared is 9 and 4 squared is 16, so we add those two together to get 25. Next problem is x cubed minus y. It says x is 2, so we need to do 2 cubed and then subtract y, and y is minus 4, so we need to subtract minus 4. That's y there. So we need to work out this bit, 2 cubed, which is 2 times 2 times 2, which is 8. And then when we have two minus signs beside each other, it becomes a plus there. So we add 4. And so we end up with 12. Next question, x squared minus y squared. And it says that x is minus 3, so it means we need to square minus 3. And then we're going to subtract y, which is 3 squared. 3, and then we square that. So, minus 3 squared is positive 9, and then we need to subtract 3 squared, which is 9, so we end up with 0. Next question, x plus y squared. X is minus 4 and y is 6, so we add 6 squared, so we get minus 4 plus 36, which is the same as 36 minus 4, so that will give us 32. And our final question on the starter is x squared plus y cubed, and x is 5, so we have to square that, and y is 2, so we are going to cube that, and so we get 25 when we do 5 squared, and we need 2 squared, which is 8, so we're going to add 8, so 25 plus 8 is 33. Okay, lovely, well done on trying that. Now we're going to look at the Pythagoras' theorem. Okay, when we're going to look at the Pythagoras' theorem, it is only linked to right angles triangles. It does not work for any other triangles, okay? So Pythagoras' theorem is linked to right angled triangles. Now here's a triangle XYZ. We need to be familiar with this term hypotenuse, okay? Now the hypotenuse is the longest side on a right angled triangle. Okay, so when we look at our triangle XYZ, the longest side would have been XZ. So XZ is the hypotenuse on that triangle we're looking at. I'll pause the video, and for these 4 triangles, I would like for you to write down the name of the side that is the hypotenuse on each of the triangles. So spend no more than a minute doing that. Resume the video to check your answer. So our hypotenuse is the longest side on a right-angled triangle. So for the first one, DE is the hypotenuse. For the second one, JL is the hypotenuse. And for our third one, HI is the hypotenuse. And for the fourth one, MP is the hypotenuse. All right, it doesn't matter which way around you write the letters, as long as you have those two letters, then they represent the hypotenuse in each case. Now, Pythagoras' theorem concerns the relationship between the sides on a right-angled triangle. As I said earlier, only right-angled triangles, okay? That's what the Pythagoras' theorem is linked to. Now, the theorem was named after a mathematician, Pythagoras of Samos. So even though he created this theorem, the idea of how the Pythagoras theorem works actually was known before he came up with the theorem. So he got the recognition for creating the theorem, really, even though the idea was already known. Now we're going to investigate Pythagoras' theorem. So your first task now is to draw these three triangles accurately. Measure the lengths accurately. So for question 1, you need to measure 3 centimeters and 4 centimeters with a ruler and create your right angled triangle. Pause the video, spend no more than 6 minutes drawing these triangles accurately, then resume the video for the next step. Now, what I'd like for you to do is to measure the length of the longest side on each of the triangles that you have drawn, and then I want you to complete this table here. So when you measure the lengths of the longest side, this is for number 1, number 2, number 3. Okay, you need to fill in the longest side. Okay, we're gonna call that's columns for column C, and then when you're through, I want you to square the length A, B, and C. Square all of them and complete that table. Pause the video, spend 6 minutes at most completing this table, then resume the video to check for your answers. Okay, when you have measured, you should have gotten 5 on triangle 1 for the longest side, and then 13 on the number 2 triangle, and 10 on number 3 triangle. So those are the lengths of the longest side for each triangle. And then I asked you to square A, B, and C and complete the table. So you'd get 9 here, you get 16 here, you get 25. Okay, then 5 squared is 25, and 12 squared 144. Okay, and then you get 169 here from 13 squared. Then you'll have 6 squared is 36, 8 squared is 64, and 10 squared is 100. Now I'd like you to focus on this part of the table that you've completed and think about if you could spot a relationship between A squared, B squared, and C squared. Okay, when we look at it closely, we can see that if I add 9 and 16, I'll get 25. If I add 25 and 144, I'll get 169. And if I add 36 and 64, I'll get 100. And this is the basis of our Pythagoras' theorem. What it says to us, if you notice, A and B are the two shorter sides, and then C in this column were the hypotenuse that you have measured. So if we take a right-angled triangle, not my best drawing, let me fix that. Okay, and try to complete it better. Right, if I take this right angle triangle, still haven't got it. Well, let me try fixing it again. Eraser. Okay, if I take this right angle triangle, label to the two shortest sides A and B, does not matter, and then the longest side, the hypotenuse, we're going to call that C. If I square this one and I square this one, when I add them, so what does Pythagoras theorem state? Let's look at, we have a right angle triangle here, and we have our shortest sides A and B, and then our hypotenuse is C. Okay, so it says for any right angle triangle, the sum of the areas of the two small squares is equal to the area of the larger squares. So basically it's the same as just squaring the two short sides. So we squared them, doing A times A, which is like finding the area of a square. So the area A, yes, is A squared, and the area of B is B squared. And he says that when we find the sum of them, of A squared and B squared, if we add those two together, then we will get the square of the hypotenuse. Okay, I can't circle that, it's red. So therefore we will actually have A squared, the shortest side squared, plus the other shortest side squared will be equal to the hypotenuse squared. Okay, so we just need to remember that. Make sure you write this formula down. Okay, once you're ready, you can resume the video to move on. Now we're going to put the Pythagoras theorem into practice. Okay, so we can use the theorem to find the longest side in a right angle triangle. We know our longest side is the hypotenuse. If we look at this first example, okay, we can see that we need to find out x, and x is our hypotenuse, or longest side. So this is our key that we're going to use to work out the longest side. We're going to square the two sides we know. They're the shorter sides. Okay, so we're going to, for step 1, we're going to square 6, which gives us 36, and we're going to square 8, which gives us 64. Step 2 says we need to add those, so we're going to add 36 and 64. So 36 plus 64 is going to give us 100. And then what we're going to do is for our third step now, which is to find the square root of that. So we need the square root of 100, and that is going to be equal to 10. So it means that x is equal to 10 centimeters. So again, we're going to square the two sides we know. Remember, we're finding our longest side. We're going to add those answers together, and then after that we're going to find the square root. Okay, so let us look at the second example. All right, so first step, we want to find our longest side, as we can see. So our first step is to square the two sides we know. So 3 squared gives me 9, and the other one, 4 squared, gives me 16. Step 2, we need to add them together, 9 and 16, and we're going to get 25. And the last step is to find the square root of 25, and that is 5 centimeters. So there we have it. X will be equal to 5 centimeters. So remember now your key. For finding the longest side, you square the shorter sides, add them together, and then find the square root of that. Now we're going to practice 2 more questions for finding the longest side. Alright, so then remember our key for finding the longest side is there in the center. You can see we need to find out what x is, and x is our longest side on this triangle. So step 1 is to square 5, which is 25, and also square 7, which is 49. Then step 2, we're going to add them together. So 25 plus 49, let's write that down. 25 plus 49 is equal to 74, and once we get that, our last step is to find the square root of 74. Okay, now the square root of 74 is 8.602325 267. So we're gonna just give our answer to 2 decimal places. So this is what I got on the calculator: 8.602325 okay. But most times if we're getting a question where we don't have an exact answer for the square root, you might be asked to round off to a degree of accuracy. For this question, I'm just gonna write it to 2 decimal places, so 8.602 dp. Alright, let's look at the next problem. Again, we need to find out what x is, and we can see clearly that it is our hypotenuse, or longest side. So we're going to follow our steps. First, we're going to square the sides that we know. And so we'll do 15 squared, and 15 squared is equal to 225. Then we're going to do 20 squared, and that is equal to 400. Our next step is to add these 2 numbers that we got from squaring. So 225 plus 400 gives us 625. Right. Now what we need to do in our last step is to find the square root of 625. And that is going to give us 25. So therefore means that our length for hypotenuse, the longest side, is 25 centimeters. Here are 6 questions that I'd like for you to try. Pause the video, spend no more than 10 minutes to do them, then resume the video to check your answers. Please mark your work. Then once you're ready, resume the video to move on to the next part of the lesson. Now we're going to use the Pythagoras theorem to find any of the shorter sides in our right angled triangle. So here's our key that we're working with. Okay, we need to find x in this example. We have 12 as our hypotenuse, so clearly x is going to be the shorter side, or one of the shorter sides. So what we're going to do is follow these steps here. Okay, first step is to square the sides that we know on the right angled triangle. So 12 squared is 144, and we need to do 7 squared as well, which is 49. But this time, because we're finding a shorter side, we need to subtract those values. So 144 minus 49 is going to give me 95. Then our next step is to find the square root of 95. Alright, so let's do that. The calculator gives me 9.746,794 and a few more decimal places, but we're going to round it to 9.75 to 2 decimal places. As I said, if you're getting questions where there are quite a few decimal places, we'll be asked to round to a suitable degree of accuracy. Okay, unless they ask you to write out what is on your calculator display. Now, why are we actually subtracting rather than adding? So for a right angle triangle, we looked at the area on the hypotenuse, okay? So the area that would be created from a square on that hypotenuse when we square the side. And this shorter side here, let's call that B, we get that square. And then on this shorter side, we get this square. When we add these two squares together, it will, if we cut it up, it will fit exactly onto the square that's on the side of the hypotenuse. And so since we wanted to find out x, yes, we'd have to subtract the area of b, that side on b, the b squared, from the c squared, and then that would have given us a squared, or the side squared. And so from there we would have to find the square root of that number to get the side itself. Okay, so that's why we are doing our subtracting. So let's look at the second example. We have this short side here, as we can see that because 15 is our hypotenuse. So let's follow our steps. We need to square 15. Okay, and when we square 15, we get 225. And then we also need to square 9, which gives us 81. Now, because it's our shorter side, we need to subtract those values. So 225 minus 81 gives us 144. Okay, and then our last step is find the square root of 144, which gives us 12. So therefore means that the length of x that we need to find is 12. Lovely. Let's look at two more examples for finding the shorter side. So x is our shorter side. We can see clearly that 9 is our hypotenuse. So we follow our shorter side steps, which is 1, we square 9, which is 81, and we're also going to square 2, which gives us 4. Because we want the shorter side, we subtract those values, so we end up with 77. And our next step is to find the square root of 77. Now I'm just going to give the answer to 2 decimal places. So let's get that worked out. That gives us 8.77 when rounded to 2 decimal places. Next example, we have a short side because our hypotenuse is 24, so we know we need to find out the length of the shorter side. So then, step 1, we square 16, and that is going to give us 256. We need to square 24 as well. 24 squared is going to give us 576. And then step 2 is to subtract them. So 576 minus 256. And that gives us 320. And our next step is to find the square root of 320. So square root of 320 is going to give me, to 2 decimal places I'm rounding, 17.89 centimeters. So that is the length of our shorter side. Here are 6 questions to try to calculate the shortest side of a right angle triangle. Pause the video, spend no more than 10 minutes to do your work, then resume the video to check your answers. Here are your answers. Please mark then resume the video when you're ready to move on to the next part of the lesson. Alright, sometimes we may be asked to tell or prove if a triangle is a right angled triangle. Yeah, we need to prove if a triangle is a right angled triangle. So here's how we're going to do it with these examples. The first one, we have they gave us 3 lengths of a triangle, and we need to find out if it's a right angled triangle. So we have the 2 shorter lengths, of course, which we'd have on a right angled triangle, and then a length that's longer than the other 2. So what you'll do is square the 2 short ones. So 9 squared would give me 81. The other shorter one is 12 squared, which is 144, and you need to add them together. So that would give us 225. Okay, then we also need to square 15, and when we square 15 we get 225. So remember that Pythagoras' theorem says if we square the 2 shorter sides and add them, if it's equal to squaring the longest side, then that would mean the triangle is a right angled triangle. So here, our first question, we have a right angled triangle. Let's look at part B. So the 2 shorter sides are 5 and 8, so we'll square them. So 8 squared gives me 64, and 5 squared gives me 25, and we're going to add those and we will get 89. All right, and then when we take our longest side and square it, we get 100. Okay, so these two are not equal. You have 89, you have 100, they're not equal, so therefore it's not a right angled triangle. However, this one is a right angled triangle. Okay, now I'd like you to spend 5 minutes working out if part C and part D are right angled triangles. So pause the video for 5 minutes, resume when you're ready to check your answers. Okay, let's check. Our 2 shorter sides are 10 squared, 10 and 24, so we need to do 10 squared, which is 100, and 24 squared. Alright, let's check that. 576. Then we need to add them together to get 676. Okay, then we need to square 26. So 26 squared is 676, and so we have a right angled triangle. Alright, let's check for D. The 2 shorter sides are 15 and 20, so we need to square 20, which gives us 400, and square 15, which gives us 225. When we add these together, we get 625, and then we also need to square the longest side, which is 25 squared, and that's 625. They're both equal, so therefore means that we have a right angled triangle. Make sure you write down examples of these. Now we're going to do some real life problems with Pythagoras' theorem. Okay, so it says a boat travels 45 miles west and 60 miles north. How far is it from where it started? Hint, draw a diagram to help you. So we know our directions: north, south, west, east. So the boat would have started at a point but traveled west for 45 miles and then traveled north 60 miles. And that would be, if you go west and then north, it means a 90-degree angle would be formed there. So if the boat started here and ended up here, they're asking you what is the distance between where it started and where it ended up. So we're looking at a right angled triangle. Now that distance they're asking us to find is the hypotenuse. So we're going to use the key or the rule for calculating the longest side, which is to square the two short sides. 60 squared, 3,600, and 45 squared, which is 2025, and then we're going to add them. So that was step 1. Step 2, we're going to add them. 3,600 plus 2025, and that gives us 5,625. And then step 3, just find the square root of 5,625, which is 75. So the distance that we're looking for is 75 miles. Part 2, question 2 says a swimming pool is 25 meters by 12 meters. If someone swam from one corner to the other, how far would they have swum? And hint, draw a diagram. So usually our swimming pool is rectangular, and it says 25 by 12, so we know we're looking at rectangular shape, which is 90 degrees, now corners. And then it said if someone swam from one corner to the next, doesn't matter what corner you choose, but you're choosing opposite corner. Yeah, so we need to find out that length, because that's telling you how far they will travel or swim. The length is 25 meters, the width is 12. So again, if we're finding this length, it is our hypotenuse or longest side. So we will square 25, which gives us 625, and we need to square 12, which is 144. Step 2, we add them as we're looking for the longest side. So 625 plus 144, and that will give us 769. And then what we'll have to do is find the square root of 769. So I'll work that one out. Write my answer to 2 decimal places, so that is 27.73 meters. Okay, we're going to look at 2 more examples. On an isosceles triangle, the equal lengths measure 10 cm. The third length is 16 centimeters. Work out the height of the triangle. So we'll sketch an isosceles triangle. The equal lengths will be 10 centimeters. The third length is 16 cm. Okay, we need to work out the height. The height here will cut the base that we're looking at, will cut 16 into 2 equal parts. So it therefore means that here is 8 cm and here is 8 cm. It will also make 90 degrees with the base there. So we can use one of the right angled triangles to work out our height of the triangle. So I'm just going to separate one of them, the right angled triangle. So we have 10, we have 8, and we need to find our height. Notice that's going to be our shorter side. The height is our shorter side, so we're going to use the rule for that. So the first step is to square 10, which is 100, and square 8, which is 64, and then we add those together for the second. We subtract them for the second step because we're finding the shorter side. So it's 100 minus 64 gives us 36, and our third step is to find the square root of 36, which is 6. So the height of the triangle is 6 centimeters. Now for the fourth example here, it says a rope of length 10 meters is stretched from the top of a pole, which is 3 meters high, until it reaches the ground. How far is the end of the rope to the base of the pole? Okay, so we have a pole, yeah, that is 3 meters high. We have the ground there, yeah, and the rope is stretched from the top. It's 10 meters long. It's stretched until it touches the ground, so the whole 10 meters is there, okay, for the rope. It says we need to find out how far is the end of the rope, which is here, to the base of the pole. So we need to find this length here, okay. Notice again that's our shorter side, one of our shorter sides, so we're going to use the rule for that. So first step is to square the hypotenuse and the other short side. So 10 squared is 100, and square 3 as well, which is 9. And we're going to subtract them because we want to find the shorter side. So 100 minus 9 is going to give me 91. And then our last step is to find the square root of 91. So let me work that one out. Alright, and if I round the answer, I get in my calculator to 2 decimal places, I get 9.54 meters, okay? So that's the length that we're looking for. Here are 4 questions I'd like for you to try on your own, okay? Pause the video, spend 15 minutes doing these questions and resume to check your answers. Alright, here are your answers. Pause the video to mark and resume when you're ready to move on. Here's a final task. It's just a bit of an extension onto what you have been doing on Pythagoras' theorem. So go to show my homework and access the link to get the worksheet. Then you can check your answers and mark as well. There's also a video link I've included to support you with the worksheet, okay. If your 100 minutes is up, send photos of your work so I can give you feedback. And if you have time to work on the extension tasks, please use the opportunity to do these, and then you can send in the work that you have done today. I hope this lesson was useful, and if at any point in the lesson you need some support, please do not hesitate to just send me a message on Show My Homework, and I'll respond to you as quickly as I can. Thank you and have a lovely day.